This video about the properties of a parent function is very helpful for your parent function projects. Let's look at the first one. It's linear function. Fx equals x. That's the linear parent function. So we try to figure out in what interval fx less than 0. Less than 0 means below the x-axis. So I will say from here's the x-axis, here's y-axis. So it will be below this. That's part for fx less than 0, below x-axis. So I will write down the interval notation for these inequalities. Is from a very left side, and there's no ending points. So it will be negative infinity, go to 0. That's the answer. So in what interval fx greater than 0, which means I'm looking for the graph is above x-axis. So very left point is 0. For the very right point for x value, it's no ending, keep going forever. So that's why I go to positive infinity. So for I, in what interval is increasing? Did you see? It's going up. It's when x increase, then the y still increase. It's going up. That means the whole thing like going up. That's why it will be from negative infinity to positive infinity. It's all increasing. So no decreasing function for fx equals x. Okay, so about the even or odd or neither, it's reflect across origin. That's why it's an odd function. And behavior, when x go to infinity, positive infinity, y still go to positive infinity. But when x go to negative infinity, see the y's go to the negative infinity too. For the limits notation for that, it will be limit fx as x approaches positive infinity equals positive infinity. And limits of fx as x approaches negative infinity equals negative infinity. That's the limit format for the meaning for those two. For absolute value parent function, and in what interval fx greater than 0, so I will draw the graph above the x-axis. I know here's the x, here's y. Then above the x-axis will be from here to here. All is above x-axis, except one point, origin this point. Here is on the x-axis. It's not above the x-axis. So I will write down this way, from negative infinity to 0, or from 0 to positive infinity. Or you can write down from negative infinity to positive infinity, except x equal to 0. But we prefer this pattern. For h, fx less than 0. So I'm looking for the graph below x-axis. None of them. We don't have any graph below x-axis. For increasing in what interval? Increasing, it will be from here to here. See, it's going up. I'm looking for the graph going up. That's why the interval for this part will be from 0 to positive infinity. Decreasing part will be from here to here, decreasing. That's why we can write down here is negative infinity to 0. It's an even function because reflect across y-axis. For end behavior, I will write down over here, end behavior. When x goes to negative infinity, y, we can check. The y will go to positive infinity. Then when x goes to positive infinity, then the y still go to the positive infinity. And write down the limit format will be like this. Limit of fx as x approaches negative infinity equals to positive infinity. Limit of fx as x goes to positive infinity equals to positive infinity. And for the quadratic function, it will be exactly same as absolute value function. So you can check absolute value part. For square root function, I'm looking for in what interval fx greater than 0. So here is your x-axis, here's y. I'm looking for above x-axis. So basically, this is the graph above x-axis. Above, that means not including the origin. So the interval will be from 0 to positive infinity. No part of a graph below x-axis, that's why it's none. Increasing, yeah, so going up. Check the graph going up. So look at the graph. Yeah, it's all going up. That's why your answer will be from 0 to positive infinity. No decreasing part for this graph. It's neither, because not reflect across y-axis and not reflect across the origin. For the end behavior, we only check when x goes to positive infinity. Then the y will go to positive infinity too. There's no points for x go to negative infinity, so you don't have to write down. Then the limit part will be limit of f(x) as x approaches positive infinity, then it will be positive infinity. And for J, f(x) greater than 0 in what interval? Which means I'm looking for the graph above the x-axis. So let me draw that. It's this graph. For this part of graph, the very left point for x will be 0. And the very right point, there's no very right points. So it's go to positive infinity. For h, in what interval f(x) less than 0? So I will draw the graph. Yeah, all this one is f(x) less than 0. So I will write down the interval. Since no ending points on the left for x, I will write down negative infinity and to 0. Increasing in what interval? Increasing, that means the graph going up. You could see all the graph going up. You see that it's going up when x increase and y increase. So that's why it will be from negative infinity to positive infinity. No decreasing function for this cubic parent function. And it's an odd function because it's a reflect across the origin. The end behavior, and we could see that when x goes to negative infinity, then the y go to negative infinity. When x goes to positive infinity, then the y goes to positive infinity. And I will write down the limit notation. Limits of f(x) as x goes to negative infinity equals negative infinity. Limit of f(x) as x goes to positive infinity equals positive infinity. For cubic root function, it will be the same as cubic function f(x) equal to x third power. We just did for previous slide. So check that out. Okay, so let's go to the rational function. And I'm looking for what interval f(x) greater than 0, which means I'm looking for the graph above x-axis. Here's x-axis, here's y-axis. So this part is above x-axis. And we could say that's between from 0 to positive infinity. And for what interval f(x) less than 0? Yeah, you could see this graph. It's below x-axis. So the very left points will be negative infinity, then goes to 0. Both is open parentheses. Look at the increasing part. Increasing part means going up. So when you check the graph, definitely we cannot find any part of a function is going up. That's why it's non-increasing function for rational function. Decreasing, yeah, it's both going down. Here it's going down. This is going down. So I will write down that it's from negative infinity to 0. That's write down for this part. Or it's from 0 to positive infinity. That's the domain for this graph. Yeah, it's a odd function because reflect across the origin. For the end behavior, when x goes to the negative infinity, you can look at the graph. The y goes to 0. When x goes to positive infinity, you could see the y goes to 0 here. It's keep going forever, but very close to 0. So the limit format will be limits of fx as x goes to negative infinity equal to 0, and limit of fx as x approaches positive infinity equal to 0. Yeah, let's go to exponential function. In what interval fx greater than 0? We're looking for the graph above x-axis. So you could see all the graph. It's above the x-axis now. That's why it's from negative infinity to positive infinity. None of the graph below x-axis. So we check in what interval it's increasing. And we could see the graph is all increasing. See, going up like this, going up. That's why it's from negative infinity to positive infinity. None of the graph is decreasing. It's neither, not even, not odd function, because it's not reflect across y-axis, not reflect across the origin. For the end behavior, when x goes to negative infinity, y goes to 0. And when x goes to positive infinity, then the y go to positive infinity. So we will write down the limit format. Limit of fx as x goes to negative infinity is equal to 0. Limit fx as x goes to positive infinity is equal to positive infinity. So let's look at the natural log function. I'm looking for what interval fx greater than 0. So we just check the graph above x-axis. So here's the x-axis, here's y-axis, and this part. So what's this point? This point will be 1, 0. That means from 1 go to positive infinity, and its fx greater than 0. And for what interval fx less than 0, I'm looking for the graph below x-axis. So I could say, yeah, this part. And it will be from 0 goes to 1. Then the graph will be below x-axis. And you could see the graph is all increasing, see, going up. That's why it's from 0. Because the very left point is very, very close to 0, but it's not equal to 0. So it's from 0 to positive infinity. No decreasing part for this function. It's neither not reflect across y-axis, not reflect across the origin. So for the ending behavior now, as x goes to positive infinity, then the y will goes to positive infinity too. Since the x cannot go to the negative infinity, so we don't have to work on that part. Then I write down the limit format is limit of fx as x goes to positive infinity equals to positive infinity. Then when x goes to 0, very close to 0, then you could see the y goes to negative infinity. So I can write down for that is limit of fx, x goes to 0, then equals negative infinity.